So Simon's algorithm in 2 minutes. Here you've got the statement of the problem. That's a really interesting one. So basically here the idea is you have a function that has a certain period. This means that at some point given two different inputs, x and y, they have the same value. So we want to find exactly what it is, what is sort of that that s that kind of satisfies this constraint here, right? So now and it's again the same like the other algorithms. You can check the other videos, the other 2-minute videos. Um, there's a bunch of mathematical definitions in here, but at the end of the day, what you see is that out of all that, you're introduced to basically a circuit at the end, which kind of it's pretty complex to break down. Um, because it's defined in hindsight out of the mathematical design of the algorithm, which is again not exactly an algorithm, but this circuit itself is the function, and it's just built in a way that it helps us get what we want. So it's a weird thing between it's a solution and the problem at definition at the same time. This exploits a really interesting phenomenon, which is the partial measurement of an entangled state. So at the end of the day, what's happening here? Let me change the color. Is that we basically here we're entangling those 4 qubits, so that when we measure these two, then we collapse half of that, and so the state that is left helps us understand really what has been applied in here. And that might be a little bit abstract, but you can take a look at the details if you want to know a bit more. But you can see here as an example, this is what you have. And when you measure, if you measure 1 1, right, then your state basically you've left with that. So because you've left with that, then you can simply apply the Hadamard as indicated, and then you end up with these, which is basically the solution that you've built. But again, that solution, that 1 1, that 11, it's really encoded in here, right? So if you would like to have a function, if you'd like to do that for a string that is not this one, you might have to change the circuit. That's the trick. It is just to prove that if you it's just to prove the usefulness of the quantum effects and things that happen when you measure a partial like an entangled state that's like you partially measure it, and then this has effects on the rest of the potential values, and that's basically it.